Hi everyone, in this video we're going to talk about the quadratic formula. So first, before we get into the quadratic formula, we need to remember how to simplify radicals. So the first thing we do when we simplify radicals is we need to check to see if we have a perfect square under the radical. So some examples of perfect squares are 1, 4, 9, 16, 25, so on and so forth. Okay, perfect square is the same number times itself. Then, if the number under the radical is not a perfect square, we need to see if it's divisible by a perfect square. I like to start with the closest perfect square to it and just work my way down until I get to 4. Next thing we need to do is to see if the number under the radical is negative. If so, we need to simplify, or we need to factor out that negative and then simplify like normal. The reason we need to simplify the negative and factor out a -1 is because the square root of -1 is an I, which gives us an imaginary number. So we have some examples where we're going to factor completely. So if I were to check this in my calculator, it would tell me that the square root of 196 is perfect, and my answer is just 14. So when it's perfect and you type it in, you'll get the exact answer and you don't have any additional work. But when I try to type in the square root of 75, it gives me some decimal, so I know it's not perfect, which means I need to break it down. So we break down 75 into 25 times 3, because 25 is a perfect square. So from here, we can go the square root of 25 times the square root of 3, and we now that the square root of 25 is 5, and the square root of 3 is not perfect, so it stays 5 rad 3, and that is how you simplify a radical. Looking at the next one, we see that now I have a negative under the radical, so I'm going to break it up into the square root of -1 times 24. Then I need to find a perfect square that goes into 24. So if I start with the square root, if I start with 25, I notice that it doesn't go into 24 evenly if I were to divide it. If I move down to 16, it doesn't divide evenly. 9 doesn't divide evenly, but when I get to 4, it divides into 6. So then, now that I have it written like this, I can go ahead and write it as 3 individual radicals. So anytime you're multiplying underneath a radical, you can split it up into 3 different ones, or vice versa. If I have 3 different ones, I could add them all together under one radical. So the square root of a -1 is I. The square root of 4 is 2. The square root of 6 does not break down, so it stays the square root of 6. So 2I rad 6 would be the simplified radical for number 3. So that is simplifying radicals. The next thing we're going to talk about is the discriminant. The discriminant of the quadratic formula tells us how many in the type of solutions that we're going to have. So if this formula b squared minus 4ac is greater than 0, then we're going to have 2 distinct real solutions, which means just 2 real solutions that are different numbers. When the discriminant equals 0, there's going to be just 1 solution. And when this discriminant is less than 0, there's going to be 2 imaginary solutions that have complex conjugates. So an example of that is 4 plus 3i and 4 minus 3i. Then it takes us to the quadratic formula, which if we have it in the form ax squared plus bx plus c equals 0, we can use this quadratic formula to help us find the x-intercepts, the solutions, the zeros, the roots. Okay, this is a method that always works, whereas factoring does not always work. So there's our quadratic formula. So we have some examples we're going to do, and we're going to work them out. So on this first one, we notice that it's already set equal to 0. So we just need to identify a, b, and c. So a is the number in front of the x squared, b is the number that is in front of the x, and c is the constant. So we have 5, 4, and 2. So then I want to start by finding the discriminant. So the discriminant formula is b squared minus 4ac. If I plug in the numbers that we have 4 squared minus 4 times 5 times 2. So when we simplify this, and it gives us a negative 24. So what this tells us is we're going to have two complex solutions, which means we're going to have imaginary numbers in our answers. So we're going to have i's. Then it takes us to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in our numbers. We have minus 4, the negatives built in, plus or minus the square root. We already found this value right here. That was the discriminant value that we found above, and that was a negative 24. And then it's going to be all over 2 times a, which was 5. So we start simplifying. We have a negative 4 plus or minus. We have already simplified the square root of a negative 24 on the front page. That would be 2i rad 6. Again, we got this from example 3. So you can go back and look at that if you need to. And then it's all going to be divisible by 10. Now, this number, and this number are all divisible by 2. So to simplify this even more, I'm going to divide each of those highlighted numbers by 2 and get a negative 2 plus or minus a 1i. You don't have to write the 1. Rad 6, all divided by 5. Now, know that this does count as two different answers. There is a plus or a minus. I'm going to fix that right there. But there's negative 2 plus I rad 6 divided by 5 and negative 2 minus I rad 6 divided by 5. And that would be our final answer. So that is two complex solutions. Looking at the next one, notice that this time it is not set equal to 0. So we do need to make sure that we subtract the 4x to the other side with its like term and add the 9 to the other side. When we do that, we get x squared minus 6x plus 9, and now it's going to be equal to 0. So when we write this, we have 1, negative 6, and 9. We go to our discriminant formula, which is b squared minus 4ac. We're going to plug in our numbers, making sure that we plug that negative 6 in parentheses squared on the outside, times 4 times 1 times 9. We type that into our handy dandy calculator, and that gives us 0 as the discriminant, which means we will have one real solution. So now we can go to the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So now we have our negative 6, so the double negatives, plus or minus the square root of 0 that we got from above, all over 2 times 1. So we start to simplify. We see that the double negatives with the 6 turns into a positive 6, plus or minus the square root of 0 is just 0, all over 2 times 1, which is 2. And so when this simplifies, it simplifies to 3, which is just one real solution. So if you want to pause the video and give 6 a chance, that would be good. So on 6, hopefully you gave it a try. We have to subtract over everything, so it's set equal to 0. So that leaves us with a 2x squared plus x minus 5, and that's equal to 0. So we have 2, 1, and negative 5. We plug it into our formula for the discriminant. That's b squared minus 4ac and that would be a 1 squared minus 4 times 2 times negative 5. And when we simplify that, we get 41, which means we're going to have two real solutions. So now that we know that, we can go ahead and plug it into the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Then we have to plug in everything. So we have a negative 1 plus or minus the square root of 41 all over 2a, which is 2 times 2. We simplify it. We have x equals negative 1 plus or minus. When you try to simplify the square root of 41, it doesn't simplify. It stays that all over 4, and that would be our final answer for this one. So if you have any questions over the quadratic formula, over the discriminant, please make sure that you ask. That way you can get some help if needed. Okay, so that's it for this video.